Welcome! Today we learn about the method of partial fractions. Fractions are a little bit dreadful topic. Did you know that 4 of 3 people do not know about fractions? So let's look at some problems. First of all, we know already some integrals which involve fractions. So let's make that simple cases. We know. So, for example, I have written you down here the plan. We know to integrate 1 over x minus 4 dx. So this is we do that with substitution, but it's so simple we actually don't usually kind of write x minus 4 as u. We just know this is the log, the natural log of x minus 4 plus a constant. There is also a second integral when we have the integral of 1 over 1 plus x squared dx. This is an integral we know. It's one of the integrals. So arctan of x plus c. And if we have terms which involve sums of fractions, like if you have 1 over x minus 4 plus 1 over 1 plus x squared dx, then we of course just can add up the integrals which we have, plus arc tan of x. But there are many more fractions. So the question which we want to solve today, or the problems we want to solve today, is how do we integrate an integral like 1 over 1 minus x squared? What is that? Or x plus 1 over x to the 3 minus 1. How would we integrate that? And the method of partial fractions tells us how to do that. We integrate this. The basic idea is to split it up into simpler parts. Because we know how to integrate that using the log. But that's actually just an algebra problem. What we have is, we have just an algebra problem which says that 1 over x squared minus 1 should be equal to a over x minus 1 plus b over x plus 1. Now we have to find the coefficients a and b. All about fractions. When you have fractions, you make a common denominator. So we have 1 over x squared minus 1, and then we just cross multiply a times x plus 1 plus b times x minus 1, and then we have the product. Oh, this is x squared minus 1. We can forget about the lower part. We have just to have an equality a is equal to a x plus 1 plus b x minus 1, which can be written as a plus b x plus a minus b. Now if you look at this equation, then this has to be true for every x, especially it has to be true for x equal to 0. So when x is equal to 0, we get a is equal to a minus b. And then we can take that away and we see that this thing has to be 0. So we have 0 is equal to a plus b. So this is a system of equations. Which we can solve by elimination. For example, we can add up both sides. We get here 2a is equal to 1. Or we can subtract them and then we get 1 is equal to minus 2b. So what we see is, let me just write this down here. So we have a is equal to 1/2. We can fill that in here. Allow me just to remove this a here and actually just write here in the 1/2. And also the b is actually, when we solve this, we get b is equal to minus 1/2. So minus 1/2 here, half. And so let's fill this in here. B is minus 1/2. Now we can just integrate this. Let me just get this integral here. Can now be written as we have 1/2 times the log of x minus 1 minus 1/2 times the log of x plus 1. And sometimes calls this residue method. But let me just show you what we do. So we multiply both sides with x minus 1. And this simplifies a little bit. So this is 1 over x plus 1 is equal to a plus, and here we have b times x minus 1 over x plus 1. And now we take the limit. We take the limit when x goes to 1. On both sides. What happens when we look at the left hand side? This gives us 2. This is a. And when x goes to 1, this is not a problem here. This goes away. This is 0. So we actually have immediately 2 is equal to a. Now we can do the same thing with the second coefficient. So this is a over x minus 1 plus b over x plus 1. Now we multiply, just make a division here. We can multiply both sides with x plus 1. That's already what we have here. Multiply this x plus 1 here. X plus 1, x plus 1. That goes away here. And we get 1 over x minus 1 is equal to a times x plus 1 over x minus 1 plus b. And now what we do is we take the limit x goes to minus 1. So if we take now the limit x goes to minus 1, what happens is this goes away here, because x plus 1 is equal to 0. This goes to minus 1/2 is equal to b. So it's a faster, we will just see an example where it's much, much faster. Here is a more challenging example. We are using the same idea. We are splitting this up into simpler parts. So we have 1 over x minus 1, x minus 2, x minus 3. We write this as a over x minus 1 plus b over x minus 2 plus c over x minus 3. And again, we are making just a common denominator. And multiply out. So what we get is a times x minus 2, x minus 3 plus b times x minus 1, x minus 3 plus c times x minus 1, x minus 2. That whole thing is over x minus 1, x minus 2, x minus 3. That was equal to, this is equal. So we can again forget about this lower part because we have just the same thing. So what we have is just a is equal to a times x minus 2 times x minus 3 plus b times x minus 1 times x minus 3 plus c times x minus 1, x minus 2. Now if you multiply this out, so there are two ways to do that. One way to do that is just multiply out, and so we get 1 is equal to, and then we take everything with the x square. So this is x square times, this is an x square, a plus b plus c. And then we have the x part, so this is plus x, and in this case it's minus 2 minus, this is minus 5a. In this case we get minus 4a, 4b, and here in this case we get minus 2, minus 3c. And then the constant part is here 6 plus 6a plus 3b plus 2c. So this is more complicated because now we have a system of equations which says that for x equal to 0 we get 1 is equal to 6a plus 3b plus 2c. Now also the x coefficient here has to be the same on this side. You can also see it by differentiating with respect to x and putting x equal to 0. You see this is actually equal to 0. Minus 5a minus 4b minus 3c. And then the last part also here, this has to be, there's no x squared on the right hand side here, on the left hand side, 0 is equal to a plus b plus c. So this is a system of equations. And if you like linear algebra, you can solve this. Fortunately, there's a much simpler method to do that, and that's this method with the residue method. What we can do is we can actually look at this. We can look at this equation here. So let me just erase all. So let's look at the residue here. The method of residues. What we do is I will just use this equation here as a base, and we just multiply everything with multiply this equation here. So that's the equation which we really want to solve. Multiply this equation with x minus 1. So if you multiply this with x minus 1 here, what we see here, this cancels away, so this is a. So what we get here, and then we get 1 over x minus 2 over x minus 3 is equal to a. And then we get b times x minus 1 over x minus 2 plus c times x minus 1 over x minus 3. And now we take the limit x goes to 1. So when x goes to 1, this is actually 0, and we see a is equal to 1 over 1 minus 2 times 1 minus 3. That's actually just minus 1 over 6. So this is 1 over 1 times 2, it's 1/2. This is minus 1 times minus 2, that's 1/2. So a is equal to 1/2. So we know already a is equal to 1/2. Okay, allow me here on the chalkboard to do this again with the other coefficients, just that we don't have to write too many things here. So I erase this x minus 1 here, and so we got that computation already. And what I'm doing now is, you guess it, what do we multiply with? What do we multiply with? Yeah, we multiply with x minus 2. Let's do that. Here, x minus 2, x minus 2, x minus 2. What we get is, we get also here x minus 2. What we get is we get the cancellation here, so we get 1 over x minus 1, x minus 3 is equal to, in this case, a x minus 2 over x minus 1. This is just b, and then we get here c times x minus 2 over x minus 3. And now we take the limit when x goes to 2. So when x goes to 2, this goes away, this goes away. It's just b here on the right hand side. When x goes to 2, we have just 2 minus 1 over 3, 2 minus 3. And again, we get 1 and times minus 1. This is actually just minus 1. So b is equal to minus 1. Last thing is we multiply this with x minus 3. If you multiply this with x minus 3 here, now we are already pros, right? And so we get here the c. X minus 3, I cannot simplify, x minus 3 I cannot simplify, but when we take the limit and take limit x goes to 3, that goes away, that's just c here. And so what we get is on the right hand side we get just c is equal to x minus 3 goes away, and then we have 1 over x is 3 minus 1, and here 3 minus 2. So that's just c is equal to 1/2. That's our last thing. C is equal to 1/2. Okay. We can now write this integral as 1/2 times log, and then we have x minus 1 plus minus 1, just minus 1 here, times log x minus 2, and then plus 1/2 again log x minus 3 plus 6. So that's the end of this computation. GoPro, stop recording. So this is a little bit a more challenging problem. Quite a few things come together here. First of all, we have to factor this out. We want to factor this into smaller pieces. So we can just see 1 over 1 minus 6 plus x squared minus x cubed. You have to find roots of this polynomial here, and you see that x equal to 1 is 1. So this is actually just 1 over, we can take 1 minus 6 out and divide through, and you actually see you get 1 plus x squared here. Just see, this is 1 minus 6, if you FOIL it out, minus 6 squared plus minus 6 cubed. So that's one of the difficulties. We have to factor it out. Now if you use complex numbers, we can actually split this up also. It's kind of 1 minus or x minus I times x plus I. We could write this like this and do it in the same way than we have done when we have done before. And so you see kind of, because there's a quadratic part here, there are actually 3 constants we want to know. But there is a little bit of shortcut here. If you don't know complex numbers, what we can do is we can just write it as a over 1 minus 6, and then we have b plus cx over 1 plus x squared. So this is also not that bad, because we know how to integrate b over 1 plus x squared, that's the arctan. This also we know by substitution, cx over 1 plus x squared, we can also solve. So if you know the constants a, b, c, we can do that. And there again, there is again just the possibility to find the constants here. In this case we have to multiply out, so we get 1 is equal to a times 1 plus x squared, and then just make a common denominator. and then we have plus b minus bx plus, just I multiply that out, plus minus x bx. Just make it slower. So 1 minus x times b plus cx, and then we have equations. Let's just multiply this out. So this is a plus ax squared plus b minus bx plus cx minus cx squared. So take all the coefficients with x squared minus cx squared, and then all the coefficients with c minus bx, and then all the coefficients without anything. This is just plus b. Now if this is equal to 1 and x is equal to 0, we see that b is equal to 1. So if b is equal to 1, and then we divide by x and put x equal to 0, so we see that c is equal to b. So c is equal to 1, and c is equal to 1. Cannot believe it. Well, I think that's right. So is it true that if we take 1 over 1 minus 6 plus 1 plus, so what we have is, so what we have to integrate is 1 over 1 minus 6 plus 1 over 1 plus x squared plus x over 1 plus x squared. So these are all integrals we know how to do. So that's equal to log 1 minus x with a negative sign, right, because of the negative here. And then we have plus the arctan of x. And here we make a substitution, and then that gives us 1/2 log 6. In this case, I did a substitution here. U is equal to x squared, du is equal to 2x dx. And that gave us this. For this last problem, we have here some x squared. We want to get that, simplify this first. So we want to write 1 plus x squared over 1 minus x squared. Let's just add 1 here. When we add 1, what we get is something simpler. When we get 1, the x squared goes away. So if we add 1, we have just we make a common denominator here. So we get 2 over 1 minus x squared. So now we can solve this and say 1 plus x squared over 1 minus x squared is equal to 2 over 1 minus x squared minus 1. So, and if we want to integrate this now, if you want to integrate this, then it's no problem. So the integral of 1 plus x squared over 1 minus x squared dx is just then 2. And we have already computed that, right? We have already computed what are the, so this is 2 times the integral 1 over 1 minus x squared dx, and then minus x plus c. Now this we know how to do, solve this by so that's how we solve the problem. And